In this video, we're going to have a look at how you can calculate simple interest using a recurrence relationship. First, let's recap on what interest is. So firstly, you can earn interest. So that's where you can deposit money maybe into a bank account, and the bank pay you back a small percentage that kind of rewards you for having money with them. So we would call this investing. And you would often do this over a period of time, and over the course of a long period of time, you get paid a little bit, and that would add to your original amount that you put into the bank. So you can earn interest by investing. Sometimes we also have to pay interest, where we have to give up money. An example of this is taking out a loan. So many of you may know people who maybe have a home loan. So that might be a situation where you really want to buy a house, but you don't have enough money to do it. So you might borrow money from the bank. And instead of the bank paying you, this time they're going to charge you interest. And this is how they make their profits. So you might borrow or loan money from someone else or a bank. And in this case, you need to pay interest to them. Some other examples of loans include credit cards, car loans, personal loans, and things like Afterpay, where you borrow the money off someone else to be able to buy something, whether it's a small thing where you might use a credit card or Afterpay. It might be a large thing like a laptop where you might take out a personal loan, or it could be something quite substantial like a car loan where you're borrowing a lot of money and you might pay it off over an extended period of time. So let's have a look at an example together. Precia has $10,000 saved and is going to invest this for 5 years at a simple interest rate of 2.35%. Let's have a look to see what parts of this little prompt we can use to drop into our recurrence formula. So we can see that Precia starts off with $10,000. So that's the starting amount. So we're going to say V0 equals 10,000. That's how much money there is at the beginning, or the initial value. We can also see that she's going to invest this for 5 years. So the number of compounding periods, so this is where how many times the interest is paid. So we're going to say in this case, n equals 5, because Precia is going to be paid her interest each year. And D, now this isn't directly in the statement, but we're going to use this to figure out D, or the common difference. So D represents how much interest Precia will earn each year, or in 1 year. So to figure that out, we can say, okay, $10,000. Now let's multiply that by 2.35 over 100. That's going to represent 1 year's worth of interest. So if you get your calculator out, type that in, we will get something like 235. So that just means D, or the common difference, or how much interest is added every year, is going to be $235. Okay, let's put this into our recurrence formula so that we can use this to make predictions and find out how much you will have after 5 years. So I'm just going to drop everything into that little template that we have. So Vn, so that just means if I want to find the value after n compounding periods, or in this case years, is going to be, well, V0 is 10,000, and I'm going to add my common difference, which is 235, but I'm going to add n lots of this. So this is my recurrence formula that I can use. Now, if I wanted to use this to find out, well, how much would Precia have after 5 years, I'm going to let n equal 5 in this case, and I'm running out of room, so I'm going to go over here. So 10,000 plus 235 multiplied by 5, and you would get your CAS calculator out to help you with this. So this is V, not Vn, but this is going to be V5, because this is after 5 years have passed. So you grab your calculator out, you type this in, and you would get hopefully something like $11,175. So how much money does Prisha have after 5 years? Well, now her investment is worth $11,175. So that's the original $10,000, and now it's grown a little bit. If we were asked to find out, well, how much has her investment grown by? So how much extra does she have now compared to last time? Or maybe how much interest has she earned? What we would need to do is say, okay, the current value, so 11,175, and then take away what it started off as. So it started off as $10,000. Now let's see what the difference is. So the difference would be $1,175. So it looks like over those 5 years, Prisha has earned herself an extra $1,175. Okay, here's another example. Sophie invests $7,000 in an account which pays 5.1% simple interest monthly. So this time the interest is going to be calculated and given every month. How much will Sophie have after 3 years? So I guess this is the thing that's a little bit different about this question. Rather than the interest being calculated each year, the interest might be calculated each month. So we need to think a little bit differently with our recurrence formula. So let's put together our recurrence formula. So Vn equals, so the initial value, Sophie starts off with $7,000. And we're going to add, now the common difference, this will be how much does she earn each month. Now, usually our interest rates are shown as a per annum interest rate or a yearly interest rate. So what we need to do to find D this time is we need to find, well, how much would she earn each month? So rather than just saying 7,000 multiplied by 5.1 over 100, we actually need to turn that interest rate into a monthly interest rate. Now, there are 12 months in 1 year, so what we do is we just divide 5.1 times by 12. Now this will give us how much she will earn each month instead. So if you pop this into your calculator, hopefully what we get is 29.75 or $29.75. So going back to our recurrence little formula that we're putting together, the common difference this time is going to be 29.75 multiplied by n. Now, in this situation, n, or the number of times, or the number of not compounding periods, the number of times that interest is paid, n represents months instead. So if we wanted to find out after 1 month, we'd put a 1 in the n spot. If we wanted to find after 1 year, we'd have to put 12 in the n spot. So this question asks, how much will Sophie have after 3 years? So to use this recurrence relationship, we're not going to find V3, we're going to find V36 because 36 months is the same as 3 years. So let's have a look. 7,000 plus 29.75 multiplied by 36. Or really what we're doing is we're adding 36 lots of $29.75. So with the help of your friendly calculator, you would have, well, the original $7,000 plus, and this part here would equal $1,071. So the total value of the investment will be now $8,071. So that's how much Sophie will have after 3 years, $8,071. Now let's have a look at a bit of a different question. Neve has $20,000 to invest. If she invests this at a rate of 3.6%, how long will it take for her investment to grow to at least $23,000? So this time we're not asked to find after a particular period of time. This time we're asked to figure out, well, how many years will it take for this investment to grow to $23,000? Now, it doesn't say anything about months or fortnights, so we're going to assume that this is going to be a yearly investment. So every year the interest is calculated. Okay, let's have a look. So V0 is going to be $20,000. Vn, well, this is what we're trying to find. This is the mystery. How many years will it take to get to $23,000? Now, we need to find the common difference. So to find the common difference, well, that's 1 year's worth of interest. So 20,000 multiplied by 3.6 over 100. That's going to be $720. Okay, now we can start to build our recurrence relationship, but we're going to use it a little bit differently this time. So Vn equals, so our starting value, the initial, or how much Neve invests at the very beginning is $20,000, plus our common difference. So every year she is going to grow her investment by $720, but we don't know n. We don't know how many years it will take for her to get to $23,000. So what I'm going to do, I do know Vn, sorry, I lied. So I do know Vn. Vn, well, we want to grow this investment to $23,000. So I'm going to put that in this spot. Now we have ourselves a solvable equation because there's only one unknown, that's n. And we can rearrange this, or we can use the solve function on our calculator to figure out the value of n. If I was to really quickly solve this, I would minus 20,000 from both sides. So we would have now 3,000 equals $720. Sorry, 720 multiplied by n. Then I would divide both sides by 720. Which gives us, well, n is just left on this side, and it gives us 4.16 recurring. Now, so it says it'll take 4.16 years. Now, because interest gets calculated every year, we can't have 0.16 every year. So we're going to say on the 5th year, Neve will have at least $23,000. We can't say the 4th year because on the 4th year there won't quite be $23,000, but on the 5th year there definitely will be. It'll actually be a little bit more. So what we've just found is how many years it will take or how many periods it will take for an investment to reach a certain amount. And you can use the same idea if it's monthly or if it's fortnightly. You'll just need to adjust your interest rate up the top.